Alright, another draft physics video presentation. That's what it is. I'm presenting. Yes, something like that. It's also a production of sorts, but yes, since it's unscripted, it's not very produced. So let us do comments, and I think there'll be enough in here to probably kill an entire video, and so maybe we will explain some things, draw them and whatnot. See how it goes. Alright, so this is a joke, so I probably shouldn't read it. Gravity is an accentuating surface angle of the Euclidean paradigm algorithm in a parabolic downtrend relative to the tetrahedron quark alignment. Yes, okay, funny. Really? I don't like jokes much. The modern mystic just watched a video of his where he's talking about rhetoric. He's going to do poems on rhetoric, which is really irritating. But I guess you're just thinking about how people communicate, and this desire, whatever, this motivation, this impulse to make jokes. Somebody falls off a cliff and you just try to lighten it up. Oh no, but that last foot was the killer. I don't know, some kind of joke. And so it is a tendency. I'm sure I'm guilty of it, but it just gets in the way of communicating, frankly. And this next comment is just an example of how communication seems like it's impossible sometimes. People just can't listen. They don't hear what you're actually saying. They don't pay attention to the words. Only like 1 in 3 of the words they hear. And you're saying, exactly how slow do I have to talk? Do I actually have to say the important words? Like importantly? Do I have to say them importantly for you to understand they're important? It's depressing to just wonder about how futile communication is. So anyway, and this is a one-way thing, This is like doing it the easy way. At least there isn't the bullshit of having to listen to other people's false premises and all kinds of other crap that is in regular conversation. So anyway, dielectric is a wiki page. Yes, I visited it. I know what a dielectric is. I'm just pointing out there's no such thing. You can't just take the word die, like it's the word pro or some other kind of stupid, whatever you call those things, and just say, I'm going to put it in front of everything. Die banana, die running, die farting, die anything. No, you can't do that. All right? It doesn't mean anything. It's just this specific substance is called a dielectric. That means a substance that is a very good insulator, but it holds charge on its surface. Okay, and like water does that, and lots of chemicals do. Oils do it, and certainly minerals can do it. So lots of things fall into a category called dielectric, where they are not very good conductors, but can hold charge on their surface. That's it. That's a dielectric. Now, dielectricity doesn't mean anything. There's no such thing. The electricity created by a capacitor isn't, and it doesn't create the electricity, right? The electricity goes in and the electricity comes back out. It's not dielectricity. It's just electricity. Electricity is a concept, a thing that happens. And it has a specific definition, and there aren't any varieties of electricity. Electricity just has voltage and current, and it can be, alternating or DC, non-alternating. But that's not even a property that matters, because that one's just kind of obvious. You're either turning it on and off, or you're not. You're switching it polarity, or you're not switching its polarity. So that's not even a change in the electricity itself. It's a change in its function. So there's no dielectricity. Okay, Ken Wheeler says the words dielectricity as if there's a certain kind of electricity that's different, that's a dielectricity. There's only electricity. And again, electricity isn't a substance. It's a phenomenon. Okay, it's something that happens to atoms. So maybe I will go to the whiteboard, or so whatever. We'll call that something. When I go to the whiteboard, we'll call that something. Something other than go to the whiteboard, because that doesn't sound that's bad rhetoric. You gotta make it sound cool. I hate this planet. I just hate it. Hate it. Here. Yeah. Okay, I'll be back. Alright, now the question is, how far back should I go? How simple shall I make it by explaining it all, or just part of it? So let's start with the all part in a sense. So I've made this argument that there's force. And the force is the stuff moving the speed of light. So whenever some phenomenon takes place at the speed of light, it takes place using these little things, and they move in a straight line. If they're not moving in a straight line, it's not going to go the speed of light. So force is communicated by this stuff. Force, free, has to be free to travel. Okay, unobstructed, without doing any crooked line kind of ways of getting somewhere. No, that won't be the speed of light then. You know, if it takes that kind of path, not the speed of light needs this to happen. And so there's this stuff in the universe, force, and it moves this speed. Alright, now this force can be in different forms. So one of the simplest forms it could be in is what we call a photon, which means there's a ray of them, okay? And the ray, by kind of definition, has to be at least two. Okay, you have to have at least two. He's a smiling, happy guy. And if there aren't two of them, there's no ray, there's no photon, okay? Because we need this thing in between called the wavelength or the frequency. Without that, you can't see this thing. So the ray could have 4 or 5 or 6 or 10 or 12 or whatever the number might be, but a certain amount of these little things at a specific distance between them moving the speed of light. Now we call that a photon, but it's really, as you can see, oh, that doesn't seem right, but anyway, we'll stick with it. That's the photon, and so we don't really think about it as what it's really made of, which is this force stuff moving the speed of light, and we don't think of it as a force, but it fits the definition perfectly because it goes the speed of light, which is really the speed of force, as I've explained before. It's just one of the things in the old days they got wrong, was to say the speed of light to describe force, because they really didn't get that, oh, all this stuff goes that same speed. So it all should be called the same thing, right? And we use the word photon when we're really talking about anything, you know, on this whole spectrum from radio waves to, you know, cosmic ray kind of stuff, is somehow fits into this category of being this stuff, photon, okay? But we don't call that stuff photons. We call it like X-rays, right? So we know the language is fucked up. The rhetoric is broken by bad vocabulary. You know, we don't have strict definitions for these things. So I'm not really challenging, you know, too much by just saying, let's understand it correctly. Forces move at speeds, okay? And that all you do is you take this force stuff and you just change it a little bit. So in this case of the photon, the whole electromagnetic spectrum, the squeaking begins. The electromagnetic spectrum is just photon. You know, it's just this stuff coming at a period. All right, and as I explained, polarization has to do with how well they're aligned and blah blah blah. So you can find all the good little physics words, but you need to understand them in the proper sequence. All right, so now these little force bits are the thing that affects electrons. Okay, so now we get to the matter bits. You know, we know that photons hit, you know, atoms, and that they create effects, and those effects are we actually see that way, right? The little photon hits the electrons move, and that creates what we say, I recognize something, I felt it. Okay, it's recognized as an interaction. So interactions happen between this force stuff and matter stuff. So to better understand that, let there be some. Now all you have to do is take this little force bit and say, well, there's two kinds of force. Okay, there's the black one and then there's the red one. And the only difference between them is this is an electron force and this one is a proton force. So you have protons and you have electrons. And it really doesn't matter what size they are because they have the same charge, which means they're affected similarly in how they function, because they both have this same amount of charge in this opposite way. So this character of being different is the same amount of difference. So this we consider to be the negative and this we consider to be the positive, which is sort of backwards, but it doesn't really matter. It's just that they have an opposite reaction to the way the universe can affect them, in the sense of how this force of different colors interacts with these electrons and protons. So as I've explained before, if the red thing hits the red object, there'll be a reflection, in the sense that a bit of force going the opposite way, there'll be an exchange. This will go inside the proton will release another force bit going in the opposite direction, so this one will come out. And this now will have a different proportion of rowers in its boat, and it will have a momentum this way. So now that looks like it breaks the equality you have to have, because in a sense, but it really doesn't, because you have one thing going this way and one thing going this way. It's just that this thing's going to go much, much slower. All right. Much slower than the speed of light. It's going to be doing something much different, because it has to spread this little tiny bit of momentum across this entire big object. So you can sort of understand that the one rower isn't going to make a huge difference in how fast the boat's going to move. And it's certainly going to make the whole boat move as fast as a rower all by himself. And so it's that kind of thing. So this changes the energy into now something, the force, into something moving much slower than the speed of light. All right, and the electron does exactly the opposite. So if the black force hits, it does exactly what this does in reverse. But if a red force hits, or if a black force hits a proton, it just leaves in some perpendicular direction. And I don't want to go into details on, well, why does it do that? Well, there's probably two interactions that actually happen. One interaction makes it go one way, and then the next interaction makes it go the other. But anyway, it leaves perpendicularly in either of these dimensions. And the right-hand rule gets into all this, some other technical crap. But just by understanding that this concept exists, that one interaction creates a reflection, the other interaction just creates a deflection. So reflection, deflection. And those are the two choices. Well, now you can understand a magnet. Okay, so magnets are same force moving the speed of light. So if I have a magnet, and I've drawn this many times, and I just keep having to go over it, because until everybody says, okay, I get it, I'm going to keep doing it. But the idea is this force, okay, which I didn't call it gravity up here, but it was basically gravity. All right, without a frequency and without being affected by polarization. See, gravity is happening to atoms, so it's happening to an equal number of charges. So you can sort of understand that if there's an equal number of these kind of things, that no matter what I throw into it, if I throw in the same amount of force in equal proportions, black and red, and I have an equal number of black and red things, that I'll end up with an outcome that's equal. So that's why gravity isn't magnetic, because there's no polar bias. But a magnet, all right, it's taking in both of the forces, come in a mixture from the universe, and they come out of the magnet polarized, in the sense that the magnet's only function is to take gravity and make it to segregate it. It just basically functionally segregates the force and just says, if you're coming in this way as red, you're going to reflect back. So that's going to look like you emitted something. And or else you're going to go straight through and come out the other side, your red color. Okay, but those are your two choices, reflection or straight through. And the same happens with the black. So all the black energy reflects, which looks like an emission, or else it just passes straight through. So you end up with an image that ends up just segregating the force. All the black stuff will look like it's coming out of one end, and all the red stuff will look like it's coming out of the other end. And it will be, in fact, doing that. It won't just look like it. It, as a practical fact, will be as it. But this explains where the energy comes from. So now we've explained all of these things. Now electricity is just a phenomenon where you take, almost have some room, these atoms. So I had a proton and electron. Well, let's just put them together, make atoms, okay? And what happens with these atoms is there can be a difference in the pressure. That is the distance between these things. So they can be close together or further apart from each other. And what atoms do, so just consider this atom number 1 and this is atom number 2. And the truth is that the electrons are always repulsive and the protons end up always repulsive based on this basic mechanism of reflection. So you can have, so if two electrons are next to each other, you can see that they're going to keep reflecting, doing this, exchanging and reflecting. So they're going to keep creating pressure between them. If you bring them closer together, there's more bounces between them, and that means more energy. The same thing's happening inside these atoms. These atoms have a tension in them. So each electron's under a certain amount of tension with the other electrons. And the amount of that tension will be conveyed when these two electrons start getting close to each other. They will have repeated bounces causing movement in the electrons, and that movement will be conveyed to all the other electrons, which will end up balancing the pressure. So say if this electron was 50 pounds of pressure, we'll just use some pressure reference, and this one was 25, okay, they'll blend, they'll mix their pressure, and they'll both end up at whatever, 30. Some other number, right? It's 35. I don't know, off the top of my head. I don't want to bother thinking about it. So anyway, they'll end up both taking that 75, cutting it half, right? Cut 75 in half, it's 36 or something. Anyway, it doesn't matter. And equalizing it. And essentially that's a flow of electricity. So electricity is this happening. This can't happen okay, way. There's no way to do this. This either happens or it doesn't happen. The material, a conductor, allows for this connection. A non-conductor, an insulator, does this connection really poorly. The atoms are so not arranged in any specific geometry or crystal. They're not tight, and therefore this can't happen. The electrons can't communicate their pressure with each other well. Or the fact is they can't change this pressure well at all. So they never change pressure. But that's the difference. Conductors convey electricity, non-conductors don't. And the fact that some atoms, some materials like water, create surfaces. The surface molecules are arranged differently than the interior ones. You can't see that. I have to go up here. So you can understand that, like a water droplet, there's a tension on the surface, and the tension is created because these atoms are tied to each other well, but these atoms aren't. And so these atoms will conduct. These atoms can hold charge, that is, they can have a polarity. Their electron end can stick out or their proton end can stick out. They can be upside down or right side up, and therefore hold charge. Charge can sit on that surface, but it can't be transmitted because these are too disconnected. So high pressure can sit on here, but it can't get through the water to a ground well at all. But if you put salt in, then you'll fix that and you'll make it electric. Okay, but electricity is a thing. Okay, it's not a thing you can play with and say there's blue electricity or there's pink electricity or there's some other kind of electricity. Electricity is the phenomenon of exchanging pressure, and the pressure is created by these little force bits bouncing in between protons and electrons and electrons and electrons and protons and protons. There's all kinds of pressure, low pressure here, high pressure here, blah 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 blah, and that's how the structure works. So it's an exchange of pressure is electricity, and there's no such thing as a dielectricity. It doesn't come in that form. Just like there's no pink electricity or unicorn electricity or God electricity or metaphysical electricity. There's only electricity as a phenomenon, not a thing. It's made of a bunch of things moving. Okay? It's not a thing. It's things moving. Okay, I think I did my job. Mostly. Now, that's just a rational, logical argument connecting the idea of a force to all of the mechanisms we see force realized, and just explaining that people can't do this. They can't call this stuff something else. And they can't call this hyperboloid. And they can't call this coaxial cable. And they can't say these stupid things to describe these events because they're nothing like that. This is nothing like a coaxial cable. Okay? It's just cannonballs moving through space at the speed of light. It's corpuscles, as Newton would say, or clumps, as Feynman would say, moving the speed of light with a periodicity, meaning they come at a certain rate, and the rate is consistent, and therefore we can detect it with instruments. If the rate isn't consistent, then we can't detect it with instruments, and we call it gravity. It's that simple. Pay attention. Okay, when I say dielectricity, it's a different word than dielectric. When I say there's no such thing as dielectricity, I'm saying something different than when I say water's a dielectric. I understand the difference, and you really should too. Bastards. Alright, I didn't want to do that. I want to do this. Alright, I'm back. So I'm going to delete that stupid comment. It's just ignorant. And again, just nonsense. Just somebody not paying any attention at all. Alright. Yeah, people are just too stupid. Alright, so Daniel, Poseidon incarnate, whatever that is, Broseidon, I don't know. Wondering what you think about this. So it's a link to the space-time crap, which I think I actually am subscribed to, which is annoying. So maybe I'll play some of that video. I don't know. So this whole idea of when did time start, who cares? First off, I guess I'd say. But I'd say there's no real way you could undo process, in my opinion. There's a process. Even evolution has a process. And it starts sort of with the idea of the abiogenesis, or the process that created the DNA molecule out of the elemental bits, you could argue. And so the universe had to somewhere create the energy, right? I mean, we can turn it all into those little tiny photons, you know, the little bits of force moving the speed of light, and reduce the whole universe to just a mass of that. And then you can imagine it being condensed, and you can imagine it banging. But that's not the Big Bang they believe in, because obviously if that happened, you can kind of understand that the speed of light stuff really can't hit each other if it's all moving in the same outward direction. One piece can't hit another piece. It's not clumpy enough. All right, this is little clumps, no big slow clumps to bang into, no slow drivers to crash into their back bumper. So nothing can really hit each other, nothing could ever consolidate, nothing could ever happen, and it's not charged anyway, so it couldn't collapse, and so it just made any sense. So the big clumps already have to be in this Big Bang thing, and so you have a process that takes place, and process just means there has to be some form of time. So I just don't see it as a very interesting argument. First, I don't think the Big Bang is a solid, hard, factual statement, okay? It's some sort of way of saying this is what we think. And you can see what they've turned it into. I mean, when I was a kid, the Big Bang was explosion, some expansion you could sort of understand, but frankly, when I was taught, you sort of get the idea that it was like a real explosion. That is, big clumps of stuff flew off, and then force bits hit it, almost like a nuclear bomb. Not everything got evaporated. Maybe in the first little part of the explosion, everything disintegrates because of the intense pressure and heat. But as soon as you get a little bit far away, their stuff is moving much slower, and the force bits are hitting it hard. And it's moving in all kinds of directions after a while. And so there's a lot more complexity to the explosion, and you can almost understand stuff swirling off and creating clumps and galaxies and all that crap. But you can't understand it as they've now described it, which is all of this. At one moment it expands 10 million times and the space is expanding, there's no explosion. Stuff isn't moving at a velocity. Instead, space is expanding. I mean, it's a big expansion. It's not a big bang anymore. So, yeah, it just can't mean much. So it might be worth playing just to goof on, to say what kind of silly thing are they going to say happened that they just made up based on almost zero evidence. I mean, there's almost zero evidence to work with. I mean, they have this stupid redshift stuff. They have a few things. And again, as I've argued, there's alternative explanations. And I think the idea of an alternating universe where the pressure gets high, pressure gets low, where gravity does in fact change over time, in my opinion, makes more sense. So anyway, oscillating universe just makes more sense. All right, Joshua Pori. Well, I heard about Miles Mathis through Vox Day and Owen. Like, we should know who they are. But these are people who, I think, I don't know, Owen might be the Norwegian guy. I'm not sure. But anyway, Miles Mathis has made accusations about people being secret Jews and all kinds of stuff, and he's gotten personal with a few people, thinking they're running projects against him when they're not, especially like people like me. Like, I have been totally upfront and honest about every interaction I had. I mean, I sent an email to Miles Mathis, years ago, 7 years ago, just asking if he wants to collaborate on something because he seemed to know some stuff. Now, I was kind of wrong about what he knows. I mean, I thought he knew mathematics when, frankly, he doesn't, because he did his pi equals 4 thing with the wrong formula. I mean, using a conversion formula to convert arc seconds into degrees instead of a velocity formula where you have to put in the friction, So I came here after a search, and hey, wait a minute, this isn't Miles Mathis. Yeah, I'm sorry about that. I mean, it's really not my fault that if I do a video griping about somebody and put their name in the title, which just seems polite if I'm going to make a video about them, that Google will index that under the other guy's name, and because Miles Mathis doesn't make any videos, no videos of his will show up. It's not my fault he doesn't make videos, right? Alright, this guy's a great big phony. He doesn't look like Mathis at all here. I know, but see, it happens pretty quickly where in all of the references to Miles Mathis, I'm pretty clear that I'm talking about Miles Mathis, not talking about myself. And anybody who really knows anything about Miles Mathis, has read any of his papers, would know that Miles Mathis would not call his channel Draft Physics. He would call it Miles Mathis. I mean, anyone who knows Miles Mathis knows he would make sure you knew his name. and I certainly don't in any way present this channel as being anything in the form of a Miles Mathis presentation. It has no appearance of that on its surface at all. Alright, I did a search for Miles on YouTube and failed, yes, but it took 2 video titles and comments to realize these are responses to Miles. I don't know why it took that long. It really doesn't make any sense why it took you that long, when I'm always talking about Miles Mathis as another person in the videos, and I'm clearly not saying anything all that great. And I'm explaining how I'm not Miles Mathis in most of the, like I said, like I'm doing right now. So you people watch this video and somebody's going to think, he's saying he's Miles Mathis. Am I really doing that? Am I saying I'm Miles Mathis? Did I just do that? I don't think I did. Some goofs and got thinking they had found Miles from their own searches. Yes, well, they'd have to be goofs, wouldn't they? So you're sort of insulting yourself, but yes, you've got to be a bit of a goof if you can't tell from just a couple of minutes of the video, less than that. It should take just a few seconds of the video to get that I'm not Miles Mathis. I won't lie, some stuff, the truther arena I like about Mathis, well then you're an idiot, because frankly it's just semantics and word games, and everybody should find that so dangerous and obnoxious. You know, that you can slander something so easily, you know, with just a tiny guilt by association. And it's terribly dangerous and unfair and rude, frankly. And everybody just say, yes, it's terribly unfair and rude, and we shouldn't support it. Like the Olympics, it's stupid. Let's not pay for it. But the man I found here strikes me as if Casper McLeod and William Defoe, SP question mark, had a third extremely intelligent brother who still knows how to communicate on a practical level in defense of himself. Well, I hope I'm talking in a practical level and in defense of himself. Okay, yes, and. Yeah, which I shouldn't have to waste my time doing, right? I shouldn't have to defend making what I consider just natural conversation, explaining what I see. You know, I should be able to say, hey, I'm having reactions to what I see. Okay, my brain is reacting, and this is the reaction. And I think I'm doing it so clearly, honestly, that why would I have to defend myself? I'm just reacting to the world that exists and making commentary. There's no chicanery. There's no, I have some ulterior motive. I am trying to trick you. I am trying to deceive you. There's just no evidence that any of that is taking place. So I really shouldn't have to defend myself. Give a old-fashioned American beatdown to someone who wrongfully attacks his person. I don't feel like being an old-fashioned American in some respects. I mean, obviously in some respects I like speaking English, and I like to understand other people, so I like them to speak a language I can understand. But beyond that, I'm not very American. Americans are kind of rude and obnoxious and pigs, and you know, made excuses for all kinds of molestations. America has, most of its history is just molested things. Attacks his person and avoids the physics in question. So that's sort of a compliment in here somewhere, but yes, thank you. Okay, I'll say that much. That's all I can, yeah. But yes, Miles Mathis is, frankly, he's a little psychotic, right? I mean, maybe all people that are somewhat intelligent end up being a little bit psychotic. He's a very good painter. He has some, and he has some rhetoric, skills in rhetoric. He writes well, but what he wastes his time writing about, I have to wonder. Well, gee, who cares? Anyway, I find these 2 articles from physics.org, and they are related to or involving magnetism. Yes, but so tangentially you're almost saying shit. But anyway, and I thought maybe they might be helpful or useful in some way. It's really irritating, actually, because again, this just reinforces fake notions people have. So I will probably have to draw a little here. The first article from a year ago, and the second was actually posted a few hours ago today. All right, and neither one's really, I mean, obviously it's all kind of, they got to hype things, and so they hype this thing as meaning something. So obviously this title is just horrible, right? Tiny vortices driven magnetic fields. So it's implying again that there's something in a magnet that's doing vortices, that's doing all this movement crap. And as I've attempted to explain over and over, none of that has happening. So I will try to give you the abstract of the article. Well, that's the way to work, yes. Yeah. All right. So this is what the article starts with, right? And it's just so kind of deceptive. At least it has the little ferromaterial, and you can see it's being swirled, but I mean, they're swirling it with magnetism. So I mean, the magnets aren't swirling it, nothing's doing that. They're just making a fluid that's capable, okay, that's the ferromagnetic material is small enough that you can create vortices of the magnetic material, and therefore create a vortice of magnetism. But it's really not all that spectacular in terms of, I don't think they're going to be able to do any of the things they think they're going to be able to do with it. My tickets to golf. Anyway, I used to like golf until all these idiots started playing it. But anyway, all right, so we're going to use magnetic fields to transfer energy. Yeah, well, duh. But anyway, so I don't know how to explain. It's just this little bits of magnetism, and they mechanically swirl it. Now, the problem with using the word vortices is everybody's, Ken Wheeler types think this is really a function of magnets, that magnets actually do something, and it's everywhere. De Hilster falls for it. Bill Gates falls for it, and I'll go through it one more time, just draw it and see if you can understand how it's just nonsense. And if they understood Maxwell at all, really, they understood what the equations are saying, and Faraday, they'd understand that they were never saying any of this crap is happening. Alright, back. We'll use green just for fun. Alright, so the, I guess I could use two colors, but it's just too much trouble. So we have a south and a north. Reverse it at your leisure. And people have this, so somebody like the hyperboloid guy, I mean, Ken Wheeler will say that there's a centripetal, a right to left tornado at the top, and then a left to right tornado coming out of the bottom, and that there's a bunch of this stuff doing this donut crap around the outside, coming out one end, and it all has arrows on it. And so regular physics does this. They put arrows on this stuff because it does have a meaning in terms of the fact is that there's a difference between the north and the south in terms of how which way the electricity will move through a conductor is dependent on this. Because electron pressure is different than proton pressure. You can sort of understand that. So they both contend that there's stuff coming out of one end and going in the other end, both sides. And so everybody sort of buys this silly image because the compass needles, if you put a magnet in this field, it will line up, in the opposite direction, north to south, representing the fact that it's going to be attracted to the opposites will attract and the sames will repel, and so these little compass needles will line up, and the little compass needles will in fact become magnets, and that their magnetic field will be exactly the opposite of this field. So as the compass needles all line up, they're going to end up creating a north-south magnet, and so obviously each one of these lines will repel each other, and that's why the lines exist. The lines don't, the filing lines, aren't the same, as the exact pressure lines, and so it needs to be understood that the ion filings aren't showing you any real line that exists. It's just showing you how much pressure there is between this magnet and this magnet, because they're both going to be the same, north-south, and they're both going to, all of them are going to be opposite the magnet that's creating the magnetism in the ferro material, and they're going to be the opposite of that. And so this is why it looks the way it looks. Now, there's no evidence for this anywhere, and there's no evidence for any other tornadoes anywhere, and all you have is the fact that, yes, when Maxwell and Faraday talked about magnetism and charge, okay, they drew it and they explained it, rationally, and they've taken that rational explanation and just turned it into something moving, and it's not a moving field. It doesn't move. So the idea is that you could start with charges. This is a minus charge. You could start with a plus charge. And the simple Maxwellian explanation, or Faraday or Rutherford or any of those people, would be as if they were to draw it. They're going to say that there's force coming off of them, off of their surface, perpendicular. All right, and that force is equal in all these directions. All right, and that these lines have a separation. And the further away you go, all right, that separation increases. And that's the inverse square law, because it's increasing in two directions. It's increasing this way and in and out of the board. And that's the inverse square law. So that's the R squared force law. And what they're basically saying is that, yes, around a charge will be this proportional line where the force will be equal at all these locations. And then when you combine charges, that line will change because there's an equalization of the force between the two objects, and so the line will change its shape. And so the idea is that when you create this dipole, that is, when you create a circumstance where both of these things exist, the lines will have a certain they'll look a certain different way than they'll look when they're individual. So but it's the same idea. So all you're calculating is, see, I really should have used two colors, really should have. All right, so you're just really calculating how much of this energy is getting there to a location versus how much of this other energy gets to a location. And that'll tell you how much there is a repulsion to the South Pole and a repulsion to the North Pole, and then there's an attraction to the South Pole from one end, and then an attraction to the North Pole from the different ends. And that'll tell you what the combined force will be on a charge at that location. And those lines for a magnet will end up looking like this. That at the front here, the lines are going to be very close together, okay, like this. They're going to be very close together, okay, so they're not going to be diverging as much, okay, coming out of the top, because the north-south orientation is going to be, there's going to be very little exposure to the south end of the magnet and a lot of exposure to the north end. So the force would be strong here in terms of attraction. And then as you go around, the magnet's going to change its position. So it's going to go from being up and down, and then it's going to start to bend a little this way. And then it's going to bend more this way. All right. And then it's going to finally be parallel again. And that's all that line represents, is where does this magnet feel like turning at that location. Now, if the ferromaterial, when they do the, dump the little iron filings on, if they were free, if they weren't stuck on a piece of paper and the magnet's in a different position, they would just be attracted and they would flip and stick to the magnet. So if they were in free space, they wouldn't sit there on those lines. They would flip and attract to the magnet. And that's what they do in a fluid. And then they'll all be sticking to the magnet in the most comfortable way. which is going to tend to be in lines, you know, and that'll be what the magnet looks like. And you won't see any of this field stuff when the material's free to move. But when it's not free to move, it's stuck on a piece of paper and it can't move in, then it will stay in a location where it's going to be trapped between the pressure between these where the first one lines up, and then the distance to the next one, and the distance to the next one. But those lines, again, aren't the same as the lines of force created by the mathematics. They're not exactly the same. But nothing's moving. Nothing's, there's no, I can't throw a piece of confetti on here, of you know, atomic confetti, and watch it go around one side and pop in the other side. There's absolutely no indication that anything is moving here. No force, no anything. Nothing's moving. Nothing is going out one end and coming back in the other. It's just wrong. It's not what Maxwell's math says, and it's not what Rutherford says, or Faraday says. What they talk about is this, straight line force. And they talk about the fact that where this force is equal, and you draw that line, then you can draw the force lines always perpendicular to this surface. Perpendicular. It's always perpendicular to the surface. Okay? It's a force radiating out. That's all it is. There's no other thing that creates this line. And all this line represents is, where is the force the same? Where is there a force of, say, 3? Well, there's a force of 3 here, 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 here. That's the line. These lines are the real lines of force. These are the real vectors of radiation. Okay. Sorry about the glare. I have to work on that. And such. So, I can't... all I can tell you is there's absolutely no experimental evidence indicating you can place a magnet somewhere and then you could sense any motion around the magnet. There's just nothing. There's no motion besides this radiation. And that radiation is just gravity going in, okay, and segregated force coming out. That's just what I explained before. Mixed force goes in, segregated force comes out. That's all that's there. That's it. That's magnetism. It's not any more complicated than that. And there's no evidence for this whole magnets make motion. They don't. That's why you have to move the magnet to change the field. If the field was already moving, you wouldn't have to move the magnet. Is that a simple way to rhetorically explain it, or logically convey it to you? If the field was already moving, why do I need to move the magnet to change the field? Alright, the second article is more like making a ferrofluid without a ferro material. So it's just making a more liquid magnet. And so it's interesting. And it's sort of, they fell on it by accident, that they could make, I can't remember what compound it would be, but that they could make a molecule, compound that had a surface that would be magnetic, and it's still a liquid. But I don't know if that has a whole lot of uses either. Alright, so here we go. Next, the reflector. You mean the same reflector they used to bounce lasers off the moon in the late 50s. So this is just idiotic. They didn't bounce lasers in the 1950s. In the 1950s, they didn't even have lasers. And they certainly didn't have gigawatt lasers that you need to shoot lasers to the moon with. You can't get through the atmosphere with a laser. Even the lasers they had in the 70s, I don't think you'd get through the atmosphere. So that's just silly. Look it up, idiots. I love when people do this. You're so confident, and yet you can't just post me a link to the article. Why should I have to look up anything? Why don't you just post me the link to the brilliantly written article that explains how lasers reflected off the moon in the 1950s? The reflector is the moon's surface, aka the dome. Now, it only became possible to reflect lasers off the surface in more recent times, in the last 30 years, because we could make lasers that were powerful enough to do that. But obviously, it works better if you have something shiny on the surface to reflect off of. And so obviously, and the reflectors work very well in the sense that they take light coming from any direction and shoot it back straight. And so, it's just kind of, you're just making a silly argument that, they're not using a reflector. Yeah, they are. And yeah, they did land on the moon. And yeah, you're an idiot. I mean, I can't even, there's so many arguments against this whole, the moon landings were fake. It's just such a silly conspiracy theory, just because of the number of people who would have to be involved in the conspiracy, and even tangentially involved. Like I said, I was almost saying that a company like Allied Chemical was fooled by the government into spending a whole bunch of money researching titanium, rocket engines for nothing. And that they didn't actually go and install them on rockets and watch the rockets take off and all. I mean, it's just a silly conspiracy theory. My father worked on some of this stuff, the titanium rocket engine stuff. And so, maybe he wouldn't have enough facts to be sure it was a fake. But I mean, it's just silly as an argument. It's just silly. It takes so little for you to be a reasonable human being and understand you're proposing a preposterous conspiracy, and that you're the one who has to have the evidence. You're the one who has to prove your outrageous claim, right? Extraordinary claims require at least ordinary evidence. You won't even provide me ordinary evidence of your claim. You're providing me silly, look at this photograph, you can see Mickey Mouse in the window. No, you can't. And all of it's explainable as reflections, as different things. You don't want to bother with the real physics. Just like 9/11, it can all be explained. I mean, you can play the actual video and you can understand, there's where the building actually fell, the whole interior of the building fell, because you can watch the blinds flying out the windows as the floors are collapsing. And you don't want to start the stopwatch until the facade starts falling. Even though you can see plainly in the video, the building's already started to fall down because all the interior floors are falling down because the wind's blowing out the windows. I mean, it's not really hard to see the facts, and you just don't give a fuck. And you're such a despicable creep. I mean, you're a dupe and an idiot and a liar and a son of a bitch. And you're just a lousy human being because you're a fake. Fakers claiming fakery. You want that, a faker who claimed fakery. You want that written on your tombstone? You despicable shit. God damn. Alright, it takes so little to look up the fact that they reflected laser light off the moon way before the moon missions. No, they didn't. They might have done it from, like, the first time they went to the moon, they didn't land on the moon. They just took pictures. They might shot a laser from the LEM or whatever to the moon and back when they were 2 miles off the surface or whatever. But they didn't do it from Earth. Shit for brain. They just didn't have it. Okay, I mean, I worked with little diode lasers anyway back in the 70s, and they cost $40, and they lasted 6 hours. And they got hot as hell. I mean, there's just no way they had a laser they could shoot to the moon. So you're a deluded kook and a liar and a piece of shit and a fuckhead. Alright, so enough of that. So I don't know if I should delete these. I mean, this really isn't good science, and it starts bringing up this vortice crap, and I've sort of responded to it, so yeah, it just creates more confusion. more blindness than vision kind of thing. It just gives people an excuse to keep jumping to wrong conclusions. Let's see. I guess I'll leave the Miles Mathis stuff. Alright, so that's enough, I think. Alright, let's see if any new physics is popping up. No, of course not. It's just so physics people are just so boring. So Tin Man guy didn't really respond to my comments, and so, well, whatever. He doesn't want to talk about the physics of this stuff. Fine. He's still doing this try to get free energy crap from magnets. I think he knows in his heart that you can't do it, but he keeps playing along, and so he turned his generator into a motor because it's not going to generate anything. It's all great, but I kind of wish I had the money and facilities to have 3D printers and all this kind of crap. I mean, somebody has to do this experimental crap. It's too bad he's wasting his time on these stupid experiments. What he ought to do is radar experiments, yes, and demonstrate that the radar doesn't do the two-slit thing, doesn't do wave interference. It's just jamming. Yeah, you should prove that for me. Anyway, so till the next time and such. Let's not do the space-time thing, right? We'll start just because it's going to be stupid. So let's just watch the beginning. It'll be stupid.
Thank you to LastPass for sponsoring
fuck you.
PBS Digital Studios. Our universe started with the Big Bang, but only for the
Says you.
right definition of our universe, and started.
Oh, yeah, that's right. So we have to consider the multiverse started before our verse. Our verse didn't start until their verse started.
That matter. In fact, the Big Bang is probably nothing like what you were taught.
Yeah, it's probably nothing like anything you conceive it to be either, retard.
100 years ago, we discovered the beginning of the universe.
Oh, see, it's just such bullshit rhetoric. 100 years ago, we figured that stuff is redshifted, and we jumped to a conclusion about what was causing the redshift, and we decided that redshift is created by space being created between the little photons. So, when I was doing the frequency thing before, their theory is that the light doesn't get stretched because the emitter or the receiver is moving. No. The frequency changes because new space pops in between all of the little pieces. Yeah, that's how stupid it is. Ugh.
Observations of the retreating galaxies by Edwin Hubble and Vesto Slipher, combined with Einstein's then brand new general theory of relativity, revealed that our universe is expanding. And
Alright, none of that. It didn't happen that way, and they jumped to a conclusion. So, and again, Einstein's theory has nothing to do with expanding universes, so that's a more horseshit. This is all about one thing. It's about redshift. They don't have any evidence from anywhere else that anything's expanding. So that's the bullshit here.
if we reverse that expansion far enough, mathematically, purely according to Einstein's equations, it seems inevitable that all space and mass and energy should once have been compacted into an infinitesimally small point.
There's no point in saying anything like infinitesimally small, because that doesn't make any sense, because we know matter is not infinitesimally small. So we can't take an infinitesimally small electron and put it in an infinitely smaller container. It won't go in there. It can't be smashed in there. Just because their equations don't have rational endings, that is, there's no energy in them, so they don't have to make the energy out of something. They don't have to make any phenomenon about anything. So they just created a curved line that has an unsustainable curve, and they're just pretending that gravity is infinite, that I can get as much as I want of it. And I'm sort of obviously arguing there's a certain amount of gravity, and that's why there's a certain amount of pressure on the surface of the Earth. It's because there's a certain amount of gravity. There's no infinite amount. There's a certain amount. See, if there was an infinite amount, we would be in infinite gravity right now, because it would be infinite. So clearly gravity is not an infinite force. You can't just get as much as you want. You can't make the well as deep as you want to make it, and it gets more and more pressure. There's a point where there's no more pressure you can add. And just like there's a speed of light, there's limits to these material things, and their stupid, dumb, idiotic equations don't have the rational limits written in them, so therefore they turn into shit and create infinite C's and create infinitely small. And that's the stupid part here. There's no way to do that.
A singularity. It's often said that the universe...
Yeah, there's no such thing. It's just a stupid math trick. It's just, yeah, so why start with these false premises? Why bother? Stupid video. We'll just jump to the middle.
No, you have to think about time in the way Einstein intended. There is no universal clock. Time is relative. Clocks are attached to each observer, each moving frame of reference.
Right, so there's no such thing as a clock that's not moving, which is just retarded. Of course, we can imagine that there's some place in the universe that's actually under equal pressure. That is, it's not being compelled to move one way or the other, like or whatever. So it's a bullshit premise. We'll start with the premise that no clock is static. That no clock is sitting in a piece of space that isn't moving. Bullshit.
Reference. To see what time does at the Big Bang, we have to trace a path through space and time back to the singularity. We trace a path called a geodesic.
Yeah, it's a geodesic. It used to be a geodesic. Now it's a geodesic.
Which, in general relativity, is the shortest path between two...
Yeah, it's just all this. This is just such horseshit. I mean, man, amazing that they can sell all this crap to people and they'll believe it. That the universe is made out of this geodesic that's moving towards the singularity, and that all of this movement takes place without there being any force. That the electrons just know, I'm supposed to go on my line to the center of the singularity. No, they don't know that.
Before the Big Bang, or after reaching the black hole's center. Okay, so I'm taking my time to explain something I already told you is wrong. But it's important because the extreme weirdness of the Big Bang...
See, they keep doing this crap too. They keep conceding, oh, this doesn't make sense because it falls apart here. Yes, and this falls apart over here. But let's just talk about all that stuff, even though it falls apart and it doesn't make sense, because we're still going to try to use it, you know, to justify, to rationalize some other piece of crap. I mean, it's like they say it's a piece of crap without, you know, I mean, this is the use of rhetoric. Basically conceding we're full of shit, but keep listening because we're going to pile some more shit on the shit.
Singularity is part of what tells us it's wrong. Anytime you encounter a singularity in the mathematics of physical theory, you have good reason for skepticism. It's probably telling you that your physical theory is incomplete.
Oh, yeah, so, okay, so he's basically pointing out how, yes, we ran into an infinity. That probably doesn't make any sense because we don't have infinite gravity on the surface of the Earth, so obviously gravity's not an infinite force. So you can't make as much of it as you want. Duh. Fucking cunts.
Someone else's Big Bang. There are some less abstract ways to get a new universe out of an old one. For example, an extreme quantum fluctuation could initiate a new...
Alright, so a thing that doesn't exist, a quantum fluctuation. So this is more crap where they invented this spontaneous activity that happens where something just poofs out of the universe because they don't understand a vacuum. They don't understand that, like a simple thing, like I pointed out, how electrons could have only 5 rowers in their boat in every dimensional plane, or in every dimensional line. They only have 5 rowers. And so if the rowers are going opposite each other, you can only have 3 and 2, or 2 and 3, you know. So you're always got a bias in a direction. So an electron could never be a static object. So once you know electrons can't be static, that is, you could take all the energy out of the universe, and the electron would have to move in one direction or the other just because of the number of seats in the boat. The boat can never have a neutral bias. It's always biased left or always biased right. Now, that just destroys this notion that free space, a vacuum, can't appear to have energy in it. But it's really not energy, because for every electron that has a bias going this way, there's an electron that has a bias going that way. you know, so, you know. But anyway, they've taken they take a tiny bit of evidence and build a whole big story out of it. And on a subject that really doesn't matter. And these are the same people who don't have energy for gravity and don't have a mechanism for magnetism. And here they are worrying about whether there was a clock before their theoretical Big Bang that is so preposterous anyway. Again, their theory is that the universe expanded, blew up, and then when, like, 4 milliseconds into the explosion, it somehow expanded, faster than the speed of light. Huge. Okay. They have all this crazy crap in there. And you're saying, what credibility does any of this have? What is this based on? What facts do they base this crap on? And there are no facts. They have redshift, and that's all they have. And they have a stupid understanding of it. I mean, the phenomenon of Doppler shift is kind of obvious in terms of trains moving or ambulances and the sound changing. Why are they turning this into something that happens in the atmosphere when it's something that happens at the emitter or at the receiver? If I'm moving away, okay, it means that each little piece of a photon or anything else can't get to me at the same time as it should, because I'm moving away. So the first little one gets to me, but the next one has to go longer distance. So obviously, it's going to seem like its wavelength was longer. Its wavelength wasn't longer, just that I'm going to turn it into a longer wavelength. And the emitter's doing exactly the opposite, where if I'm moving towards something as I'm throwing these things out, I'm going to throw them out at a rate, but because I'm throwing them out closer to the object I'm heading for, the spot on the road is going to be closer together. So I'm going to force it to be a new frequency. That's the simple explanation. You don't need any space filling voids and all this crap. Expanding space. It's a silly explanation. When you know what causes it, why are they making up this new mechanism when they know that's not how Doppler shift works? Sorry, there's no point in me asking these rhetorical questions, because these physics cowards won't answer any of them. Because they're physics cowards. They're all cowards who protect themselves from scrutiny. Fuck. 12,000 likes, 293 dislikes. For just a complete rubbish. This is a rubbish subject. When did time start? It's a rubbish subject. You don't have enough evidence to draw any conclusions. You don't even have enough evidence to even speculate, frankly. Alright, so enough. Until the next time and such. So forth and whatnot.